Good morning, student, and welcome back to all of you in the physics class. In the previous class, already I have started the fourth chapter, and the fourth chapter it was pressure in fluids. Pressure in fluids. In this chapter, I have already given the definition of the thrust, given the definition of pressure, given the definition of lateral pressure as well as fluid pressure. And last topic that I have explained in the previous class, that was the law of transmission of pressure, that was the Pascal's law. So today I am going to start the application based on the Pascal's law. Okay, today I am going to start the application based on the Pascal's law. Okay, so before starting the application based on the Pascal's law, firstly you must be knowing what was the statement given by Pascal. Okay, so statement given by Pascal. So right now I am going to explain the definition, the statement that was given by Pascal. According to Pascal's law, whenever the pressure is applied to the any part of the confined liquid, whenever the pressure is applied to the any part of the confined liquid, it is equally transmitted in all direction. It is equally transmitted in all direction irrespective to its area. That means according to the area, it will be equally transmitted. Okay, and it always act right angle to the containing vessel. It always act right angle to the containing vessel. Now, this thing already explained in the previous class. Okay, so today I am going to start the application that is based on the Pascal's law. Application based on the Pascal's law. So applications. There are few things that we are using in our daily life that is based on the Pascal's law. That is the hydraulic press, hydraulic brakes. These are the perfect examples by which we can prove this thing, by which we can verify the Pascal's law, and that is based on the Pascal's law. Okay, so today I am just going to explain some application that is based on the Pascal's law. So today I am going to start the hydraulic press. Hydraulic press. Hydraulic press is based on the Pascal's law. Hydraulic press is based on the Pascal's law. How we can? So it just see it take two vessel, two cylinder. One cylinder having the small in area, and second cylinder is having the larger area. Take two cylinder. Okay. Here we are applying the pressure, and here some load is kept. Here load is kept. Okay, suppose this one is the P part and this one Q part. This area is small a and this area is capital A. Okay, water is filled in this one. This one P, this one Q, this area is capital A and this area is small a. Okay, there are two cylinders I have taken. One cylinder having the small in area and second cylinder is having the small bigger in area. This cylinder, small one I have supposed it P and bigger one I have supposed it Q. Okay, this one is having the small in area, so its radius will be also less, r, small r, and this radius suppose it will be capital R. Okay, and here one piston is attached. Okay, and both side fluid is filled. Okay, in both the piston fluid is filled, and see it here, both is connected. That means a small cylinder as well as the bigger cylinder, both is connected through a pipe. Okay, both is connected through a pipe, and here piston is also attached. So once we are going to apply the pressure, see it here, once we are going to apply the pressure onto this cylinder P, so whatever the pressure will be applied, it will be transmitted to the fluid that is filled in the cylinder P. Okay, and since here no space, so this same pressure, that thing you have applied in the smaller side, it will be transferred to the larger side. Okay, and here just see, load is kept, load L is kept, and here we are applying the effort E. L is load and E is effort. Okay, L is load and E is effort. So from the smaller side, by the use of piston, once we are going to apply the pressure in the downward direction by the use of the piston, then the fluid that will be kept in the smaller cylinder, since it is attached to a thinner tube, so whatever the fluid that will be present in the smaller cylinder, it is transferred to the bigger area side cylinder. Okay, and the same amount of pressure will transfer to the this side, and if any load is kept onto the bigger side, that will be moved in the upward direction. Okay, that means here we are going to apply the pressure in the downward direction, and here since the pressure is transferred from the smaller cylinder to bigger cylinder, so once the pressure will transfer from a smaller cylinder to bigger cylinder, so according to the law of Pascal's law, the pressure is equally transmitted in all direction. That means if the pressure is going to transmitted in all direction equally, then in this condition, whatever the pressure applied onto the smaller side, same pressure will be also applied onto the bigger side. So whatever, or the thing that will be kept here, load that will be kept above the bigger side, above the cylinder Q side, that will be uplift in the upward direction. Okay, that means by this way we can say the pressure is equally transmitted in all direction irrespective to its area. Okay, now if we want to find how much the mechanical advantage will produce over here, so if we want to find how much the mechanical advantage will produce over here, so for this you have to do few things you have to find out. Okay, firstly you must be knowing what is the pressure applied over here onto the smaller side. So pressure exerted on the side P. So formula for the pressure equals to force upon area. So force, it will be in the term of effort. Force, it is given in terms of effort. So effort E upon area is how much I have supposed? Area is, this side area is small a. This side area is capital A. Okay, here area is capital A and here area is small a. So E upon A. E upon A. Now, according to the Pascal's law, whatever the pressure you are going to apply here, the same pressure will be also experienced by the liquid. By the liquid or by the fluid. That means whatever the pressure you are applying by the piston, okay, whatever the pressure you are applying on the piston, the same pressure will be transferred to the given liquid. Okay, so pressure exerted by the liquid. So if we want to find the pressure exerted by the liquid, so whatever the pressure it will be applied here, same will be also here, E by A. Small e by capital E by small a. Okay, now if we have to calculate how much the thrust will act, how much the thrust will act, what the definition of thrust I have explained in the previous class. The force acting normally onto the on the given surface is called thrust. The force acting normally on the surface is called thrust. Okay, so on that basis, thrust on the side Q. What is formula for thrust? Thrust equals to, what is the formula for pressure into area? Pressure into area. So pressure is E by A and area on the side Q. According to the Pascal's law, whatever the pressure you are going to supply here, same pressure will transfer onto the this side. Okay, whatever the pressure you are going to apply here, the same pressure will transfer to this side. That means here we have applied the pressure E by A and the same pressure will transfer here. You can also write here by Pascal's law. By Pascal's law. Okay, so if the same pressure will transfer over here, so here already you have calculated the pressure exerted by the liquid is E by A. So that means if the pressure is exerted by the liquid on this side is E by A, so same pressure will transfer to this side. So once the pressure will transfer, all the pressure will transfer, that means according to the Pascal's law, the pressure is equally transmitted in all direction. So if it is equally transmitted in all direction, that means if the pressure is here, this side is E by A, so through this pipe, since it is both the cylinder is conducted through a small pipe, so if the amount of pressure is here is E by A, so here also it will be E by A. Okay, now since the force acting normally on the surface is called thrust. Okay, so on that basis we can calculate how much the thrust will act onto the bigger side. Okay, so definition on the basis of definition, thrust equals to pressure into area. So pressure E by A and area on the side Q is, how much area is given on the side A? Q is A. So capital A. Okay, now according to the definition of the equilibrium, okay, the downward force equal to upward force. Okay, the downward force equal to upward force. Okay, so here this pressure is applied on the side Q and this side is the load. So this one pressure applied, this one force applied, thrust is acting on here and the load is also balancing here. That means this one applying pressure this side and this one also load is acting in the downward direction. That means both will be equal to each other if the body is this one is in equilibrium. So that means in place of thrust on the side Q, we can write capital L equals to E by A into A. Got it? Then L by E equal to capital A by small a. Okay, and in the class 10th it is given mechanical advantage equal to load upon effort. Okay, mechanical advantage equals to mechanical advantage equal to area of the larger piston upon area of the smaller piston. That means mechanical advantage will be more if mechanical advantage is directly proportional to the area of the larger piston. That means here it will lift the load. Okay, so we can also say this thing, mechanical advantage area equals to pi r square. So mechanical advantage equals to radius of radius of larger piston, larger cylinder, large cylinder upon radius of small cylinder. It will be square because area is pi r square. Here also pi small r square. Pi cancelled out. So we can also write mechanical advantage equal to capital R square by small r square. This thing also we can write. This one is the formula. Okay, that means here we have verified that is mechanical advantage equal to area of the larger piston upon area of the smaller piston, or radius of the larger piston, larger cylinder upon area of the smaller cylinder. Okay, these things we can verify it. Now this one is the based on the Pascal's law. This one is the general diagram I have drawn, but once you will go it in large complete exact diagram, so it can be used for different purposes. And sometime some students have also seen the where it is used, the hydraulic press. Okay, it is used for compressing the straw and cotton bales. What is the use of the hydraulic press? It is used for compressing the straw and cotton bales. First one. Second one, it is used in automobile sector. Third one, it is used for extracting the oil from the oil seed. Okay, it is used for extracting the oils from the oil seeds. Third one, it is used for punching the holes. Basically, you have seen this one. Sometime a machine that is used for making the holes in the metal. Okay, so that means the same apparatus you will use, not same one. I'm just going to draw it, and from the diagram I'll explain it how it will work. But you must be knowing hydraulic press is used for compressing the. It is used for. There are a lot of use of hydraulic press. First one, it is used for compressing the straw and cotton bales. Second one, it is used for extracting the oils from the oil seed. Then third one, it is used for making the punching the holes in the metal. Okay, it is used for punching the holes in the metal. Okay, and then it is also used for giving the shape of the metal. Once it is going to compress it, then it is used for giving the shape and proper structure to the metals also. Okay, these are the basic uses of the hydraulic press. Okay, this one is the general diagram I have drawn, and on that basis I have explained this one. Right now I'm going to draw the diagram by which I can show you how it will work, and someone also have seen this one in the automobile sector as well as for the place at which they are making the holes in the metals. These things also you have seen. See, simply I am going to draw the diagram. Just try to understand from the diagram. There will be a container. Okay, it is filled with water. Small cylinder. This one, see it, I am going to draw it. You can also draw by the same method. It's one lever. Okay, this one is the diagram. Here some load is kept. Okay, load L, and here it's a wall V1, and this side wall V2. Okay, this side wall V1, this side wall V2. Okay, on this side here it is releasing wall, here such V2. Okay, now see it, this side is the lever is attached. Okay, and here is it's the piston also, piston as well as lever also. Try to understand from the diagram that just see it. This side is the smaller cylinder, this side is the bigger cylinder. Okay, here it is water is there. Okay, and here it is known as pump foot valve. And this one is called press foot valve. Okay, now see it. Why it is known as pump foot valve? See, lever order, it can be open once it is moved in the upward direction. Once lever by which lever we can move the piston in downward direction as well as in upward direction. By the use of lever we can in upward direction as well as in downward direction. The major role of this lever is to shift the piston in downward direction as well as in upward direction. In both direction we can lift it as well as we can press it also. Okay, so once we want to once we will lift it, okay, and see it here below it there is a water level. Okay, so once we are going to lift it, so this valve will move in the upward direction. Okay, try to see from the diagram, try to understand. Okay, once we are going to lift it, then in this condition valve V1, that is pump foot valve, it will be moved in the upward direction. And once it will move in the upward direction, so whatever the amount of water that will be here in this container, it will be moved in upward direction. Moving by upward direction, that means it will suck the water in upward direction. Here it will come. And once it will come, firstly what you have to do it, you have to lift the lever. By the use of lever order, you have to lift the piston in upward direction. So once it is going to move in upward direction, so it will move in upward direction, so this valve will open. This valve V1, it will open, and once it will open, then after that immediately apply the pressure, shift the lever order in downward direction, and once the lever shift in downward direction, so it will close. Okay, once the lift, this piston will move in upward direction, so this ball will open, and once the ball will open, so it will suck the water in upward direction, and once it will suck the water in upward direction, immediately once it will fill, then immediately push it, then immediately it will close, and once it will close, so since it's according to its name, pump football, we are going to pump it, and once it is going to pump it, that means shift the piston in downward direction, shift the pump in downward direction, pump football in downward direction. Okay, then immediately piston will move in the downward direction, then this ball will close, and once this ball will close, then pressure will transfer here. Okay, according to Pascal's law, and once the pressure will transfer over here, then here press football will there, then it will apply the pressure, it will apply the pressure. That means immediately once it will apply the pressure, this V2 will open in upward direction, because already this part will close in this condition, and here also applying the pressure this side, here this valve is also closed, this part is also closed, and this part we are applying the pressure, so entire pressure will transfer here and it will move here, and this valve V2 will move in upward direction, and once it will shift in upward direction, so the amount of liquid that is kept here, or the amount of pressure that is present over here, it is transferred here, and once it will transfer here on the larger side, immediately the amount of load that is kept on this side, it will be left in upward direction. Okay, and here releasing ball, it is also known as releasing ball, it is also known as, here I am going to write, releasing ball. That means if you want to release it, if you want to regain the proper position, so here whatever the amount of water that will be here in this side, larger cylinder side, by the use of this release valve, you can release the water in the given container. Okay, by this way this hydraulic press will work. Okay, got this one? The diagram, the previous diagram, general diagram by which how you can find the mechanical advantage, that I am explained, but this one is the exact construction by which you can do the you can use the hydraulic press. Okay, there are different uses of hydraulic press, already I have explained. It is used for compressing the straw and cotton bales, first one. Second one, it is used for punching holes in metals. Third one, extracting oil. Fourth one, giving a specific shape, to the different metals. Okay, these are the uses of the hydraulic press. Okay, this one is the uses of the hydraulic press. First one, compressing the straw and cotton bales, punching the holes in the metals, extracting oils from the oil seeds, and this one, giving the specific shape to the metals. This one is the uses of the hydraulic press. Okay, now the next topic is hydraulic brakes. The next application that is used in the by using Pascal's law. That is the hydraulic brakes. basically basically the hydraulic brakes is used in the heavy vehicles. Heavy vehicles, that is the bus, truck, car, etc. Not bus. Then heavy vehicles happen 16 wheels vehicles or 18 wheels vehicles. That will be used in hydraulic brakes. Now see the how we can. It is also based on the Pascal's law. See how we can draw the diagram of the hydraulic brakes. This one is the wheel. Try to see how I'm going to draw the diagram. It's a very easy diagram that you can draw it also. Just see it. This one is the master cylinder. Okay, this one is for second wheel. This one is the lever system. This one is the brake pedal, brake. Here it's brake shoes. This one is the wheel. This one is the restoring spring. Okay, got it. And this one is the small cylinder. This one is the diagram of the hydraulic brakes. Just see it properly, and you have also seen how I have drawn it also. Okay, this one is the diagram of the hydraulic brakes. Now come to the construction of this one. Here it's a master cylinder. Inside the master cylinder there will be a thicker oil will be filled. Okay, inside the master cylinder thicker oil will be there, and here it's just like here it will be a piston will be there. It's a piston. Once you are going to apply it here pressure, it will move in upward direction. It will move in the inside direction. Okay, here it's a lever system. What is the role of lever system? By the use of lever system we can apply the pressure onto the piston. Okay, by the use of the lever system, just like in a hydraulic press you have seen, I have used the lever system. In the same manner also here also we have to use the lever system. By the use of lever system, we will apply the pressure onto the piston, and that piston will also apply onto that piston will also apply pressure onto the master cylinder in which the thicker oil is filled. Got it? Now come to the here. So see it here. Here it's a brake. That means you have seen in the car, in the bus, the those who are applying the brakes, by the brake paddle it is there. Okay, brake paddle. That means here they are applying the pressure. Okay, then here master cylinder. This one is the master cylinder. Here is the thicker oil it is filled. Thicker oil. Why it will be thicker oil? Because it will apply the more pressure onto the wheels. That's why we have to use the thicker oil. More the density, more the thicker oil will be there, density will be more, and if density will be more, so more pressure it will be applied onto the brake shoes, and immediately the wheels will stop the vehicles. Okay, now see it here. Here it is connected to a pipe. Here it's for second wheel. Second wheel, that means just like here you have connected, it is for the second wheel also. Not only one side, both the side brakes will be there. Back side also brakes will be there. Front, back also. So this one for second wheel. Now here brake shoes is there. Brake shoes, it will be inside the wheel. Then after that here it's a small cylinder. Just like here master cylinder will be there. In each and every wheel there will be also small cylinder will be also there. Just like the functioning of this one, same functioning also of this one. Okay, but here only apply the pressure in one direction, but this one applying the pressure on both the direction. Okay, see it here. It's a restoring spring. The role of restoring spring is to restore the original position of the brake shoes. Okay, and here see it, brake shoes already given, wheel also given. Now here also wheel is given. Now see it here. Once we are going to apply the brake shoes here, apply the pressure onto the brake paddle, brakes, apply the pressure onto the brakes, immediately it will shift to the lever system, and once it will shift to the lever system, it will also apply the pressure onto the piston, and once it will apply the pressure onto the piston, the piston will also apply the pressure onto the master cylinder in which the thicker oil is filled. Okay, see it properly. It's a very easy concept. Once you will able to understand what the thing I am going to explain it properly. Just you will draw it also. You can draw it also, as well as you can write it also in your own word. So see, once you will apply the pressure onto the brake paddle, immediately it will supply to the lever system, and since the lever system is connected to the piston and that piston is attached to the master cylinder, so once we will apply the pressure onto the brake paddle, immediately it will shift to the lever system, and lever system will apply the pressure in the inside direction to the piston, and piston will also move inside, and once it will move inside, then in this condition the thicker oil that will be present in this one, in the master cylinder, it will move in downward direction. It will move in downward direction, and since already by Pascal's law you are knowing that whenever the pressure is applied to any part of the boundary of the confined liquid, it is equally transmitted in all directions. So whatever the pressure you are going to apply over here, since the thicker liquid is reaching here, and see it here, it will here also both side piston will be there. Here piston will be there, so it will expand, because once the thicker oil will comes here, reach here, immediately it will apply the pressure also this side. It will also apply the pressure this side. Both the side it will apply the pressure, and once it will apply the pressure, so it will expand in outward direction, in this direction. Okay, once the thicker oil will reach over here, since already pressure applied from this side, so it will, since both the side pistons are there, this side also piston is there, this side also piston is there, and if the piston is attached, so it will immediately, it will expand, and once it will expand, then it will apply the pressure onto the brake shoes, and once it will apply the pressure onto the brake shoes, so brake shoes will immediately apply the pressure into the onto the wheel. Since see it here, it will apply the pressure onto the brake shoes, and brake shoes will apply the pressure onto the wheel. This side also same thing. Piston will master cylinder, this thicker oil will apply the pressure onto the piston, piston will apply the pressure onto the brake shoes, and brake shoes will apply the pressure onto the wheel, and immediately once the pressure is applied onto the uh, wheels by the use of brake shoes, immediately the vehicles will stop. Okay, and if you want to regain the original position, so what we are doing, we are releasing the brakes. Okay, not releasing the brake, remove your leg by on the from the brakes. Okay, brake paddle, and once you will apply, once you will release it, then immediately by the use of restoring spring, you can regain the original position of the brake shoes as well as wheel. Okay, by this way you can use the, by this way the functioning of the hydro by the use of this one, brakes will properly function. Okay, so this one is the construction of the hydraulic brakes. I think all of you have got this one. Okay, this one is the two application that was given by Pascals. Okay, hydraulic brake, hydraulic brake, and hydraulic press. Now come to the next topic, that is the atmospheric pressure. I think these things are, everything is, every point is clear to each and everyone, I think so. Okay, now come to the next topic. Now, already I have explained the definition of pressure. What was the definition of pressure I have explained? Whenever the force is applied onto the unit area, so that is called the pressure. Pressure equals to force upon area. Okay, but atmospheric or atmosphere definition I have not explained. Okay, so first of all you must be knowing what do you mean by atmosphere. Our earth is surrounded by the envelope of an air. Okay, our earth is surrounded by the envelope of an air, which is commonly called atmosphere. Okay, our earth is surrounded by the envelope of the air, that is called the atmosphere. Okay, now our earth is also there are a number of layers on the earth surface. Above the earth surface there are a number of layers, so the approximate height is of the atmosphere is around 300 kilometer. The height of the atmosphere is around 300 kilometer. Exactly it may be 298 point something, but around 3 kilometer you can 298.7 kilometer, but exactly you can write 300 kilometer, better write. Okay, so this one is the atmosphere. Now come to the next definition, that is the atmospheric pressure. The force exerted onto the unit surface area. The force exerted by air onto the unit surface area is called what? Atmospheric pressure. Just like the definition of pressure, I have given the definition of pressure. Force upon area is called pressure. Force upon area is called pressure. In the same way also we can define the force exerted onto the unit surface area is called atmospheric pressure. Now, how we can show the effect of atmospheric pressure? Okay, how we can show the effect of atmospheric pressure? There is an experiment that by which we can prove the effect of atmospheric pressure. Now, experiment is there, crushing can experiment. By the use of crushing can experiment, we can explain the effect of atmospheric pressure. Okay, take a mobile oil can. Okay, filled it with water. Don't take complete filled with water. Take 250 ml to 300 ml of water. Take it. Okay, supply the heat. Supply the heat. Okay, continuously open the lid. Open the lid. Okay, take a can and mobile oil can, and in that can take the 250 ml to 300 ml of water and continuously supply the heat. Okay, until and unless the vapor is not coming out. Okay, then after that remove the burner. This one is the burner. Remove the burner. Once what you have to do it, take a neat and clean mobile oil can, then take 250 to 300 ml of water. Okay, open the lid, supply the heat from the burner. Okay, continuously supply the heat until and unless the vapor is not coming out. Then remove the burner and apply the cap. Okay, remove the burner and apply the cap like that. Close it. Close it. Okay, once you will close it, immediately the can will crush. Immediately the can will crush due to the atmospheric pressure, because whatever the vapor will be there inside the can, it will be converted into the water, and due to the atmospheric pressure, it will crush. Here, atmospheric pressure outside. Inside, see it. Again, try to understand this one. Take a mobile oil can, fill it 250 to 300 ml of water, supply the heat, continuously supply the heat. Once the vapor is going to start coming out from the can, from the lid, then immediately remove the burner. Then after that, apply the cap onto the mobile oil can. Okay, then after some time, once you will pour some cold water, once you are going to pour some cold water, okay, immediately after pouring the cold water, the can will crush. Why can will crush? Because the whatever the vapor will be, that will be inside, it will be immediately change into water, and due to the atmospheric pressure the can will crush. By this way we can say the atmospheric pressure is acting onto the this can. Okay, now I hope so whatever the point, whatever the thing that I have explained it today, all of you have got, and I hope so that the thing that I am explaining in each and every session, all of you are also revising. Okay, and some numerical that is based on the laws of motion as well as motion equation of motion, I will also solve it in the next coming class. Okay, thank you.